When working with very large tables, it can be challenging to efficiently manage and query your data. Table partitioning in InterSystems IRIS makes this easier by dividing table data across multiple databases according to a user-defined scheme. Even though the data is physically separated, it still behaves like one table to your applications. Partitioning splits the rows of a table, and the associated indices and streams are separated based on the same scheme. This ensures index queries continue to perform as expected. One benefit of partitioning is that it allows you to move subsets of your data to different storage tiers. For example, you can keep recent, frequently accessed data on premium storage while moving older data to a lower cost tier. Another advantage is improved query performance achieved through a process called partition pruning. With this optimization, only the relevant partitions of a table are scanned during a query, making execution faster and more efficient as tables grow larger. Partitioning can also make data operations more efficient, since new data can be added to different partitions in parallel, avoiding the risk of contention found in non-partitioned tables. Managing your data is also easier. When deleting data, for example, entire partitions can be moved at once, which simplifies processes like archiving. The two main types of partition tables are default partitioned and key partitioned. Default partitioned automatically splits data based on row ID, requiring no specific configuration. This can improve the performance of delete operations and ingestion for very large tables. If you'd like more control over how your data is partitioned, you can use key partitioned. This allows you to determine the logic behind your partition structure. Consider which fields are often used to filter rows. These fields, for example, US state, can then be leveraged as the partition key. In key partitioning, there are two important decisions: how you partition the data and where those partitions are stored. The partition key determines how your data is partitioned and is chosen during the design phase. The three main key types are range, list, and hash. Range partitioning is the most common and splits data into intervals such as per month or year. This is ideal for time-based data like transaction logs. List partitioning creates one partition for distinct value, such as region. This works well when the number of distinct values is relatively small and meaningful. Hash partitioning distributes rows evenly across a fixed number of partitions using a hash of the key value. This is useful when you have many distinct values and want a balanced data distribution. To control where the data is stored, InterSystems IRIS lets you map partitions to different databases. Mapping is done via a set of simple SQL commands and can be defined and adjusted at runtime as your needs evolve. Let's walk through the process of creating and partitioning a table for patient visits in a hospital. First, we'll create a few databases to simulate different storage tiers for different years, such as visit date 24, visit date 23, and visit date archive. Next, let's create the hospital.patient visits partition table using range partitioning based on the partition key field visit date and specify a 1-month interval. InterSystems IRIS will automatically create a new partition for each month as data is inserted. Inserting a few rows of sample data, you can see that each is automatically placed in the correct partition based on the visit date field. We can inspect the partitions for the hospital.patient visits table by querying the related catalog view. This returns the partitions defined by the table's range partitioning. At this stage, the table is logically partitioned, but all partitions still reside in the namespace's default database. We can now group the monthly partitions and store them in databases organized by year to balance storage and simplify long-term data management. With the move command, the partitions with 2023 monthly data goes into a database called visit date 23. With the same command, we can move 2024 data to the 2024 database and older data to an archive database. After performing these operations, the table remains logically the same, but the data is now distributed across multiple databases. Let's run a query, filtering by date range. When InterSystems IRIS processes this query, it evaluates the visit date condition to identify partitions that contain matching rows. Using partition pruning, the query requests data from 2023 and accesses only the monthly partitions for that period. This reduces the amount of data scanned and improves performance. Partition pruning does not interfere with previously defined indexes. It narrows down the scanned data so your query can use the most efficient index. By combining logical partitioning with flexible storage placement, table partitioning helps databases scale to very large datasets while maintaining strong query performance, making it possible to manage growing data volumes efficiently.